So the last one we're going to look at is about circumscribed angles. A circumscribed angle is an angle whose sides are tangent to the circle, like in this figure. So line AB and line CD are both tangent because they cross the circle only once. So angle B, which is formed outside the circle, is a circumscribed angle. Now, according to this theorem, the measure of a circumscribed angle, angle D, is equal to 180 minus the measure of the central angle that intercepts the same arc. So, in other words, this is the angle that we're looking for. Okay, so that's the angle that we're looking for. It has two intercepted arcs, the major arc and the minor arc. So which arc are you going to use? You're going to use the minor arc. In this case, I'm not saying it's minor arc all the time. So we're going to use the minor arc that is corresponding to the central angle. There you go. So you can think of this as a quadrilateral. This looks like a kite, right? So that's both of these are radii. So these two radii are congruent to each other. And we learned previously that tangents, to the circle, are perpendicular to the radius. So if you're going to compute for these two, since they are equidistant from the same external point, then they must be congruent as well. So you can think of this as a kite. So in this kite, to find angle D, what you're going to do is subtract the measure of this angle, which is directly across angle D, from 180. Okay. So think of it in terms of quadrilaterals because it makes it easier. So to find angle D, you subtract the angle across it from 180. Well, why is it true? Well, because if this is a radius and that's a tangent, that's perpendicular, right? So that's 90 degrees. This must also be 90 degrees. So that means 90 plus 90 is 180. Take it away from 360. That means you have 180 left. So if you want to find this angle and you know the central angle, then just subtract that from 180. So let's write that down here, and that will be our last notes for today. So let's write down our number 6. It's called the circumscribed angle, and it's formed by two tangents. There you go. And the vertex is outside the circle. So we put the angle is equal to 180 minus the central angle, or I will just say minus the opposite central angle, just so you will be reminded that the central angle is found across it. So just write it down, write a neater version. I'll try again. This is kind of hard to write with, but it's faster than typing. So, okay. So, what was I writing? So angle, the circumscribed angle is equal to 180 minus the central angle. The central angle. I was trying to put opposite over here. So if you're going to look at it in terms of a kite, then the circumscribed angle is directly across its central angle. Alright, so once you're done with your notes, go ahead and do some examples on how to use a circumscribed angle in computations. And then there's some more exercises that combines everything that we learned. And then you're going to upload your notes, and well, every lesson comes with a practice or an assessment, so you're going to do that last. So I'm going to end this screencast with some more examples. Let me find that. Example 3, and clear this ink. Let me see if I can pull up example 3 over here. In the first example, we want to find angle QSP, or X. So that is a circumscribed angle because it's formed by two tangents outside the circle. So to solve this, we got angle is equal to 180 minus the corresponding central angle. I'm just going to put letter C for central angle. So that means central angle. Okay, so x is equal to 180 minus 124. There you go. So the final answer will be 56. Okay, so x is equal to 56. Now for the last example, there is no direct relationship between 42 and x. So remember, in the formula, you need the central angle, but we don't have the central angle here. However, we can draw a segment from A to O to B. So that's your central angle. So to find the central angle, we're going to use the same formula I wrote earlier. It's 180 minus C. So that means the angle, which is 42, goes here. So the circumscribed angle is 180 minus the central angle. So that gives you C is equal to 138. So how does that help us find x? Well, this is angle x, and it's formed by two chords. Oops, sorry about that. Let me erase that portion. So we can take out the green one also. Okay, so we know that this is an inscribed angle. Why? Because it's formed by two chords and the vertex is on the circle. So that means if C, or the central angle that we got earlier, is 138, this arc, the corresponding intercepted arc of this inscribed angle, is also 138. So that means to find the inscribed angle, which is x, we know that it's 1/2 of the intercepted angle, which is 138. So if we divide 138 by 2, then that's going to be 69 degrees. So we had to use this formula for the circumscribed angle so we can find the measure of this inscribed angle. Alright, I think my kids are calling me now, so I'm gonna leave you with that. I hope the examples help, and yeah, so just go back to Schoology and try to finish this by the end of the week. Okay? Have a good one. Bye-bye.